So you've done lots of area with things like parallelograms, trapezoids, triangles, quadrilaterals, all sorts of fun things. Today we're going to talk about area of composite figures. That means, well, let's look at the definition. A composite figure is made up of two or more shapes. So if you think about the word composition, it means you're putting things together. So composite is the same base word as that. So to find the area of a composite figure, we need to break down the figure into shapes whose areas you will know how to find. Find the area of each individual shape, then add them together. So truthfully, each problem is a little more work because there's more than one shape, but it's not complicated. It's a little longer because there's more than one shape in each problem, but it's not complex. So our first step is to determine what shapes make up the figure. Then we'll want to determine the dimensions of each shape, whether that's base or height or length or width or radius or whatever. Then we'll find the area of each shape. And lastly, we'll add the area of each shape together. So those are our steps that we'll follow for each of these examples. Okay, so first up, we want to find the area of this composite figure. So hopefully you can see we have two shapes here. Right here, we have a parallelogram. Right here, we have a triangle. So as weird as this shape may look as a whole, it's really just two basic shapes we know how to find the area of. So a parallelogram, its area formula is base times height. And the base for this one, okay, it's 17 feet. Because remember, this side down here and this side up here are identical. So we usually think of the base as the bottom, but the bottom and the top have the same length. So we can just say 17 feet is the base. And then they show us the height over here, 9 feet is the height. So 17 feet times 9 feet gives us 153 square feet. But remember, we're not done because that did find the area of the parallelogram, but we want to find the area of the whole thing. So a triangle, the formula is half times the base times the height. Our base for this triangle is 8 feet. I know it feels upside down, but you can think about it that way. If you flip this upside down, then it makes sense. Oh, that is the base. So the base is 8 feet. And the height is this dimension right here. It's 10 feet. It's also the length of this side over here, if you wanted to use that, 10 feet. Half times 8 times 10 is 40. So if you look back at our instructions, we've done steps 1, 2, and 3. We figured out we had a parallelogram and a triangle. We figured out the base and the height for each one. And we found the area for each one. So our last step is to add those two areas together. So we do 153 plus 40, and we get 193 square feet. Okay, on number 2. We have two shapes. We have a triangle. And here we have a semicircle, meaning half of a circle. So for the triangle, and it doesn't matter which one you do first or second, we do half times base times height. Our base would be the 6 millimeters, because you think about it this direction, that's the base of the triangle, 6 millimeters. And its height, again, if you're looking this way, its height is 16 millimeters. So the base is 6, the height is 16. So we multiply those together, and we get 48 millimeters squared. Sorry, I should have circled that. It's not the final answer, but that is the area for the triangle. Now, the area of a circle, a full circle, is pi r squared. But we're wanting to know the area of half of a circle, because this is only half of a circle. So we put a 1/2 in front of this. So if it's a full circle, the area is pi r squared. If it's a semicircle or a half circle, it's 1/2 pi r squared. I don't know if you'll face any quarter circles, but if you do, then it's 1/4 pi r squared. So all we need is the radius, but we got to make sure we're careful here because the 6 millimeters is not the radius of the circle, it's the diameter. So we need to take half of that and plug it in for the radius. So our radius is actually 3. And you can type this in your calculator, 0.5 or 1/2 times pi times 3 squared, or you can just say times 9. If we round to the nearest tenth, that's 14.2 square millimeters. So we have the area of the triangle, we have the area of the half circle, then we add those together, and the result of the composite shape, or the area of the composite shape, is 62.2 square millimeters. Okay. Oh no, it's the back page. That means this is where the tricky part comes. Okay, you're right. But the tricky part this time is sometimes the problem doesn't directly give you all the dimensions that you need. But the good news is, all it takes to get what you need is a little bit of adding or subtracting. Give me just 1 second. I gotta do one thing before I forget. Where are we? Okay. Now back to our regularly scheduled broadcast. Okay. So we're still following the same process. It's just we'll have to do a little extra work, and truly just little, not a lot, to figure out all the dimensions that we need. So this time our two shapes are a rectangle, and this includes the whole thing, not just this individual one, but the triangle. So let's do the rectangle first, or if you want to think of it as a parallelogram, that's fine too. It is that. But the area of the rectangle is straightforward. Length times width, or base times height, whichever one you want to call it. So that's going to give us 23 times 15. So the area of the rectangle, if you do that in your calculator, you'll get 345 square inches. Now for the triangle, that's the one where I have to do a little bit more work. The area is half times the base times the height. So let's think about the triangle in this direction. So the base is this entire line right here. But they didn't give us the length of that entire line, at least not in one number. We know this little segment right here is 6 inches. This little segment right here is also 6 inches. And then we actually do know this middle part because they told it to us over here. It's the 15 inches. So this part is also 15. So if we add all three of those together, then our base is 6 plus 15 plus 6. So that's a total of 27 inches. So that's where we had to do some adding in order to figure out the dimension they didn't give us clearly. They gave us all the information to find it, but it just tell us, hey, the base is this. So now we do the formula. Half times the base, which is 27, times the height, which is 8. So the area of that triangle is 108 square inches. So we've got the area of the rectangle here, the area of the triangle here. If you add those two together, you get 453 square inches. Okay, next shape. It's actually two rectangles put together. And just, there's two ways you could correctly solve this problem. If you wanted, you could split it up by drawing a line here and saying we've got a rectangle all the way up and down here and this segment over here. Or you can separate it this way. So we've got this rectangle up here and this one being the tire base. Totally up to you. It doesn't matter which one. I'm just going to go ahead and split it up right here. But there's nothing wrong if you wanted to split it up this way instead. You can get the right answer either way. Okay, so we'll just call this rectangle 1, call this rectangle 2. Okay, so for rectangle 1, it's easy to see this dimension. Let's call that the length. But this dimension, we have to add the 5 feet and the 3 feet together. Because if this is 3 feet, so would this dotted line be. So we've got to add the 5 and the 3 together to get this length. So that's a total of 8. So again, for this first rectangle, this dimension is very clear, it's 3. For this one, we've got to add 5 and 3. That's how we got the 8. So for the first rectangle, it's 24 square feet. Now for the second rectangle, this one is also clear, again 3 feet, but 10 is the length of this entire side. So from this point to this point is 10 feet. But we're only going from here to the dotted line. So if you look up here, we know this is 3 feet, so this little segment is also 3 feet, which means this segment must be 7 feet, because we got to make sure 3 and 7 add up to 10 to make the entire side. So I'm going to pause a second and let you look at that. So again, 10 feet is what this entire length was equal to from here to here. But the way I chose to split up the rectangle, we only want it from here to here. Well, since this small segment is 3 feet, what's left over must be 7 feet because the two pieces added together have to add up to 10. So for this rectangle, rectangle 2, it's 3 times 7, which is 21 square feet. Add 24 plus 21, you get 45 square feet. Okay, last one. We actually have 3 shapes here. On top, we have a trapezoid. On the bottom, we have a trapezoid. And in the middle, we have a rectangle. So let's start with the trapezoid on top. I'll call it trapezoid 1. So the area for a trapezoid is half times the height times base 1 plus base 2. Okay, they gave us the height right here. That's 5. That's easy enough. And we have one of the bases, which is 18. Now, 18 goes all the way the long way, so 18 is this one right here. So to find this base, we have to look down to this side. So this base is 18. This base that's going from here to here is 10. So we do 10 plus 18 or 18 plus 10. Doesn't matter which way you do it. But when you multiply all those together, you get 70 square feet. So just moving top to bottom, I'll do the rectangle next. Length times width. So we can see 18 feet and 20 feet are the two dimensions we need. So 18 times 20. And for the rectangle, that means we have 360 square feet. Now, good news, even though they were cruel enough to put 3 shapes here, the trapezoid down here, if you look, it's identical to this one up here. Like, there's no differences in their dimensions. This is 10, this is 18, the height is 5. So since trapezoid 2 is congruent or identical to trapezoid 1, we know its area is also 70 square feet. So we've now found the area of all 3 shapes. We found the area of both trapezoids, they're each 70 square feet. And we found the area of the rectangle, which is 300 square feet. So if you add 70 plus 360 plus 70, you get the composite figure shape, or area, which is 500 square feet. So the key to lots of problem solving is breaking it down into simpler pieces. So when you look at these shapes as a whole, it may be like, there is no way I can figure that out. Once you break it down into pieces that you do know how to figure out, it makes it simpler. So make sure you make a habit of following the steps on the front of the page, where you identify what shapes we have, figure out their dimensions, then their areas, then add them together.